Thank you, thank you. Yeah, good to be here. Thanks for coming, everybody. Today we're going to be talking a bit about the scaling technology and tooling of Polkadot. I gave a presentation at the Shared Security Summit a few days ago, which covered some of these topics. This is going to be a little bit more builder-focused, but essentially we've been doing a bunch of research and taking a deeper look into this concept of block space. So what is the raw material? What is the product of blockchains? I think it's very easy to go deep into the stack and say like, oh, here are all the different layers and here are all the different details you have to tweak. But what really matters, especially from a builder's perspective, is this concept of block space. It's the raw material. So I define block space as the capacity of blockchains to execute and finalize operations, right? Pretty straightforward. It's a general material that needs to be specialized into intermediate or end products. And as a builder who's building something, some kind of on-chain institution, smart contract suite, something like that, this is what you're actually consuming. So different block space offerings from different systems are going to have different properties, right? Like block space is not uniformly the same, but when you're looking at the details of different stacks, I kind of bring it down to these three properties of quality, availability, and flexibility. So quality being, how secure is it? What is the economic cost of reverting finality of this block space? How permanent is this product that you're buying? Availability being general availability on the market. And to be clear, this is not the same thing as scalability, right? Because scalability is about increasing the supply, but not necessarily creating a healthy market for block space. So availability is about supply as well as the allocative efficiency of the system for getting that block space. And then you have flexibility, which is how many different ways can it be used? Is this very general? Is this a restrictive model? Is it something like Bitcoin, right? Where Bitcoin is programmable, but it's not Turing complete. There are limited things you can do with it. EVMs versus ZK EVMs versus WebAssembly. These things have different properties. And I'll dive a bit deeper into that because I think from the developer's perspective, flexibility is very important. So to get back to that point that block space is not a commodity, but a class of commodities, right? Different systems are going to be producing different types of block space. Now, each system is producing that commodity, that's its commodity, but across all systems, it's a class of commodities. And as we build in a multi-chain world, getting the right quality of block space is important because you're going to build apps, you're going to build institutions on chain, you're going to build businesses, contracts, and they're going to need to draw from many different sources of block space. And the analogy that I like to use is that drawing on, let's say, mostly good block space and a little bit of bad block space is like going to a restaurant and getting served a meal that's mostly really good ingredients, but then the chef sprinkled a little bit of garbage in there, and it's not something you'd want to eat. And it's really the same thing with low-quality block space, because as soon as you introduce that into an application, you introduce a high level of systemic risk, that can lead to cascading effects and take down the whole system. And that's why I call it toxic and say that multi-chain applications are only as good as the worst block space that they build on top of. It is a raw material, and it needs to be specialized per use case. And we kind of break this down into two models. You have autonomous models and you have reactive models. So reactive being somebody sends a transaction or a message comes in and the system reacts to that. So smart contract models are inherently reactive in that they respond, they react to incoming inputs. But you can also use block space for autonomous inputs. You could say allocate 20% of your time to just doing maintenance tasks or moving things around in state or cleaning things up. There's no reason that block space necessarily needs to be spent on reactive inputs. That's not to say that reactive inputs are bad. Actually, they're very, very useful because this is how you ultimately interact with users and build a product. However, when you combine that with an autonomous model, it becomes more powerful. So I've already spoken out this slide, but to get that more concretely in text, we have it defined as autonomous models being where the system is executing pre-programmed tasks, and reactive models being ones where block space is allocated in reaction to incoming transactions. And we can talk a bit about this notion of flexibility, along with the metering mechanism, right? What happens when you're doing granular operations versus coarse operations? Now, when you're doing granular operations, like executing in a VM that's not specialized for a particular use case, you have to say stop after every instruction, deduct a little bit of gas, and then move on. And this is a pretty high overhead. So per instruction metering is good because you can do anything with it, right? These languages are very low level. It's stuff like moving around memory, adding numbers, basic instructions like that, but it has high overheads. Whereas if you meter things purely on the basis of data and execution time, that's a much coarser building block that you can then build coarser instructions on top of, right? You can have something like, what is the gas cost of storing a file? What is the gas cost of doing a swap? And swap being sort of like one instruction, one operation that you don't have to meter for every single instruction that's being done there. So this notion of transforming block space into intermediate or end products I think is really important. And I think of smart contracts as one of these block space transformers. Application-specific blockchains being another. So you can build a smart contract to transform block space into a product that way, or build an application-specific blockchain as a transformer. And to be clear, scaling is important, but allocative efficiency is just as important, right? If you were making a new continent, right? Like imagine you have all the continents of the world got a little bit bigger, and there's a new continent, and that continent could have all the land, right? Like tons of land, more land than all the other continents put together. But unless there's good mechanisms for allocating that land, it's not really useful. It's kind of a free-for-all, right? It's just a big battle. So you need effective markets that are efficient for allocating that resource. And I think especially, as we're in a bear market right now, it's not 2020, it's not 2021, leaking tokens in order to pay for more block space than you need before product market fit, before there's a really active user base and sustainable economy is not something I think projects are going to be able to do, which is why we're really leaning into this allocative efficiency argument. So to talk a bit about the tooling, right? Like how can you build on Polkadot, right? With this in mind, like what are some of the block space transformers that you have access to? Now, you have access to all the VMs that you are familiar with coming from Ethereum, right? You have basically good access to the EVM. And the idea is that you can deploy contracts to parachains, what we call parachains. I'm not sure how many people here are familiar with that term. The parachains paper, Polkadot white paper in 2016, was actually the first optimistic rollup paper. So when you see parachains, if it's a term you're not familiar with, just think rollup. You can build a parachain, right, with an SDK, with Substrate that I'll talk about in a little bit. You can build modules, reusable modules that can be plugged into different parachains, or you can build bots, essentially off-chain actors for things like MEV, incentivized actors, state cleanups, that kind of thing. So those are a lot of different ways to sort of transform that block space into something useful from like a tooling perspective, like actually writing code. To talk a bit about Substrate, Substrate is not just a Polkadot SDK. It's something we've dog-fooded for Polkadot in the sense of we wrote Polkadot using this blockchain SDK and implemented all of the off-chain networking, database, all of that stuff on top of Substrate. But the core of it is it's a modular architecture. So you have pluggable consensus, swap in different consensus algorithms, and then you can swap in different bits of business logic with pallets. So you can use it to write parachains. I know teams that are using it to write rollups on Ethereum, or even data availability layers that are meant to be solo chains, all kinds of things. And one of the approaches of Substrate, which is opt-in, is this notion of forkless upgrades, because runtimes are just big WebAssembly blobs. So they're stored on chain, and they encapsulate all business logic. So upgrading logic is just a matter of taking the previous WebAssembly blob and forklessly upgrading it to a new one. And the whole Substrate meta protocol, as we call it, kind of encapsulates that, so you can swap something new in very low friction. And, of course, extensible off-chain logic. Like, we have dog-fooded all of this advanced networking stuff using Substrate. I think it's very suitable to those types of tasks when you want to get deeper than just building something that's an atomic on-chain state machine. Talk a bit some of the palettes we have. We have EVM palettes, have been built in the community. stuff like balances, stuff like staking, NFTs, cross-consensus messaging, transaction fees, and all of this stuff is swappable. And any kind of palette, DEXs, NFT platforms, whatever you might think of, stuff that's well suited for gaming, marketplaces, whatever you might find, that can be implemented as a palette and then put into many different chains. And this is a very, very, very non-exhaustive list. I want to talk a little bit about Ink. It's something that's been launching recently, but it's essentially a Rust-based domain-specific language, or DSL, that targets WebAssembly for smart contracts. And if you're curious to dig into this, the documentation is up. I think it's quite comprehensive and very, very intuitive at the URL use.inc. And this is definitely worth exploring if you want to dive into, say, writing contracts in Rust, and you get some benefits of that, like maybe easier formal verification, first-class like LLVM support, all the optimizations that come with that, strong type system, really good test suites, that you can write with the Rust tooling, and all of that stuff. So to talk a bit about this from the builder perspective, and I don't think I have much time, so I'll leave it here. I have a few more slides, but catch up on the talk from the Shared Security Summit if you want to dive deeper into this. But the argument that we want to make for builders is that we're pioneering this approach of doing for block space what cloud architectures did for server space, with efficient allocation of resources, basically making it as easy as possible for early stage teams to only pay for the block space they need and scale up when they need it and scale down when they don't. Do this in an automated way. I'll leave off for there. Thank you so much for coming, everyone, and have a good rest of your ETH Denver.